Hello students, today we are going to discuss how to draw tangent theta. In the first example we will discuss how to draw tangent theta with 180 degree period, which is its actual period, followed by another example with period other than 180. So please watch my video completely for your comprehensive understanding, and like my video and subscribe my channel. Okay, let's draw it. Student, this is the first standard form. Y equals to a tan x plus c. Here a and c are two different constants. C is axis of curve, and a, which is the coefficient of tan x, we will not call it amplitude of tan. We have already studied that in case of sine and cosine sketching, that the coefficient of sine and cosine is called amplitude, and it gives us the maximum distance from the axis. But in case of tan, this value a will not representing that amplitude, because there is no maximum or minimum value in tangent theta, but c will be known as axis of the curve. One thing that I would like to highlight here, in the standard form you can see that the coefficient of x is 1. So this is the first standard form. In the next standard form you will see that we will have something in the coefficient. So in the first standard form that we will discuss now, we will have 1 in the coefficient of x. So that's why its period is 180. Period 180 mean when you will start putting values of x from 0 to 180, you will have values, some may be positive or negative, but as you will start putting the values after 180, you will see that you will have the repetition of the values, because in trigonometry there is no limit of angle. So in a certain interval you will have some values of set, and this set will start repeating after a certain interval. So the interval where we have different values of set, basically this is the period. So from 0 to 180 you will have a single set of values, and after that you will have the repetition. Moreover, you can see that here tan 90 is undefined. So tan 90 will not give you any defined value. It means that when we will draw the tan from in the domain where we will have 90, so there will be the break in the curve. So at tan 90 we will draw a vertical line which is called asymptote line. This asymptote line basically is a vertical line, and in the example, in the coming example, you will see that when the curve approaches from 0 to 90, it will getting closer to the vertical line, asymptote line, but it will not touch it. So similarly, after the 90 there will another the part of the curve which will approach to the 90 but will not touch it. So at that point we will have the break. And similarly, student, here you can see that, let me remind it, these are the 4 quadrant. We have the coordinate plane, and we have 4 quadrant, first, second, third and fourth. Here a mean all positive in first quadrant, s means second quadrant, sine is positive, and all other function tan and cosine are negative. In the third quadrant tan is positive, and in the fourth quadrant cos will be the positive. Okay, let's solve an example. Student, the example is 2 tan x plus 1. Here you can see that the coefficient of x is 1, so it is regarding the first form, y equals to a tan x plus c. Here on comparing the example with the standard form, a is 2 and c is 1, and the domain of the variable x varies from 0 to 180. So this domain will tell us that from which value to which value we have to take the values on horizontal axis. So a is 2 and c is 1. We will find c plus a, which is 1 plus 2 3, and c minus a, 1 minus 2 is minus 1. You will have to find these values whenever you are going to draw the trigonometric function tan. These value will help you in sketching the curve. So these are not the maximum or minimum values, but these values are required in sketching. Okay, let's sketch it. Students, c plus a, 1 plus 2 is 3, c minus a, 1 minus 2 is minus 1. These are not the maximum or minimum values, because I already told you that there are no minimum or maximum values in case of tangent theta, but these values will help us in sketching. So in all the cases, in all the examples, you have to calculate these values. Here the domain is 0 to 180. Similarly, the period of tan x is 0 to 180. So it is simple that draw the horizontal line, mark these values 0 and the last value 180, and divide this whole length into 4 equal intervals, 4 equal parts. 0 to 180, half of this is 90, 0 to 90 is 45, similarly 90 to 180 is 135. So this process is very similar as we did in case of sketching of sine and cosine. Let me tell you one thing more. This vertical dotted line, this is a very important line, and it's a very important part of the sketching. This is called asymptote line, and it must lies on the middle value of the period. I repeat, asymptote must lie on the middle value of the period, and it should be vertical. So here we have 180 degree period, so it should lie on 90 degree. Similarly, you can see another horizontal dotted line. It is representing the axis of the curve. C is 1, so y equals to 1 is the axis of the curve. C plus a is 3, so we will have 1 2 3 on vertical axis, and c minus a is minus 1, so here we have minus 1. Now for sketching, you will take this first value 45, and this first value, which is the middle value of the 0 to 90, I mean the middle value from 0 to 90, it must pass from c plus a, and this is the first part of the curve, and in the first quadrant you know that tan is positive, so it should be above the axis of the curve. Moreover, tan is always start from the axis, so I repeat that you have to start the curve of the tangent always from the axis of the curve. So in the first part it will start from 1, which is axis, and from the midpoint it should pass from the c plus a. Okay, you can see that as the curve will approaches to the this vertical line, so it will getting closer and closer to it but will not touch it. Similarly, in the second part you can see that from 90 to 180, this is the second period, and tan is negative, so the curve should be below the axis. It will start from the axis, but it will be in the lower part, and here it will, the mid value of this, it should pass corresponding to the C minus A. So that's why C plus A and C minus A are important to calculate, because the mid values always pass from C plus A and C minus A. So in this way, student, you can complete your sketching. These mid values are very important. If you want, you can you may not mention these values, but these values are required. You can just take the reference, okay, from this and this. But if you want, you can ignore these values in writing. Okay, student. The same question for the domain when x varies from 0 to 360. So we will have 4 different quadrants here. The process will remain same. Now the domain is from 0 to 360. So we will divide 0 to 360 into 4 equal parts on horizontal axis. Half of 0 to 360 is 180, and half of 0 to 180 is 90, and half of 180 to 360 is 270. So here, because the period of tan x is 180, so 180 times 2 is 360. So we will have 2 different cycles of this sketching. For the first value, the mid value, which will be the 45, I haven't mentioned it. You can mention it, but it is not necessary to mention it. Just have the reference of this mid value. So mid value, it should pass from the C plus A, which is 3. So in this way, we will have the first part, as in the first quadrant tan is positive, so it should be above the axis of the curve. In the second part, in this part, because in second quadrant tan is negative, so it should be below the axis, and it should pass from C minus A. Similarly, in the third part, from this and this make one cycle. This part and this part make one cycle. So from here to 0 to 180 we have one cycle, and from 180 to 360 we will have another cycle. So similarly, from 180 to 360 we will have the asymptote line in the middle value, which is 270. So from 180 to 270 we will just treat it like the first quadrant, as we did in 0 to 90. So in third quadrant we know that tan is positive, so its curve should be above the axis, so it will pass from C plus A, which is 3, and from 270 to 360, which is fourth quadrant. So here the curve should pass from C minus A, and it should be below axis of the curve. So the second cycle, which start from 180 and ended at 360, it should be very similar to the first cycle. So in this way you can sketch your curve from 0 to 360 or beyond than this. The second standard form is y equals to tan bx plus c. Here you can see that there is a one difference, that the coefficient of x is not 1, the coefficient of x is b. So the period for this standard form will not be 180, but it will be 180 upon b. So whatever we will have the coefficient of x, we will divide the period upon value of b. So similarly we will have the corresponding changes in the values of the horizontal axis. So we will divide each value upon b and we'll get the corresponding value. So 90 will become 90 upon b, 180 will become 180 upon b, 270 will become 270 upon b, and similarly 360 will become 360 upon b, and the same process will be carried out with the mid values of these intervals. Okay student, the example for regarding this Standard form is 2 tan 2x minus 1. Here value of a is 2 and value of b is 2 and c is minus 1. C minus 1 representing the axis of the curve. So the period of this tan 2x will not be 180, but it will be 180 upon 2, which is 90. So 90 will be the period of this function tan 2x. The domain varies from 0 to 180. So 90 times 2 is 180. So we will have 2 cycles of this curve. C plus a is 1 and c minus a is minus 3. We will use these c plus a and c minus a values in the sketching because we know that the upper part must passes from c plus a and the lower part must passes from c minus a. Domain of this example is 0 to 180. So we will take horizontal axis. This is 0 and this is 180, and we will divide this whole length into 4 equal parts. 0 to half of 0 to 180 is 90, half of 0 to 90 is 45, and similarly half of 90 to 180 135. As we calculated that the period of tan 2x is 90, so 0 to 90 we will take its half, which is 45. So the first asymptote will be at the 45, because this is the rule that the first asymptote must lie on the half of the period, and the second, in the second cycle, it should be, the asymptote should be in at the middle value of 90 to 180, which is 135. So we will draw this asymptote line vertically. Similarly, the axis of the curve is at minus 1. So this is our reference line, because the curve must start from the axis of the curve. So the curve will start from the minus 1. As we have calculated, the c plus 1, c plus a is 1 and c minus a is minus 3. So from 0 to 45, actually this is our interval where the sign, where the tan will lie in the first quadrant. So the curve should be in the upper portion, in the upper part of the axis of the curve. So we will take this midpoint. You can just consider it, or you may mention the value, or you may ignore this value, but you have to take its reference. So corresponding to this mid value, the curve must pass from c plus a, which is 1. In the second part of the curve will start from the axis, but will passes through the c minus a, which is minus 3. From 45 to 90, basically the tan will be in the second quadrant, so it should be below the axis of the curve, because its value will be negative. And so from here to here, this and this part make up the first cycle. So from 90 to 135, the tan will be in the third quadrant, which is positive quadrant for the tan. So it should be in the upper side of the curve, and should pass through the c plus a 1. And similarly we will draw the this part, which is the fourth quadrant for tan 2x. Just remember, we have tan 2x, so we will have to multiply these values with 2x. So correspondingly we will get the fourth quadrant from 135 to 180. So the curve should be in the below part of the axis of the curve, and should pass from c minus a. So student, in this way you can draw tangent theta for any period 180 or other than 180. So I think you fully understood the concept. Thank you very much.